Then Yeah. Hello, everyone. Good morning or good evening. Can you able to hear me?
Yeah.
Okay, so let's continue with the next topic. All right, so in today's session, we'll be starting with our Kubernetes module. Okay, and here we'll see the fundamentals, the overview of Kubernetes, and then we'll be discussing about the architecture, and we'll be talking about the components of Kubernetes architecture. And then we'll be learning about some of the terminologies or concepts. Okay, terminologies or the concepts. Right. And once we are clear with the terminologies and concepts, we'll see how to install Kubernetes. Working with Kubernetes. Right. And as part of the terminologies and concepts, I'll give you what are the topics we're going to cover in this module. Okay, like as per your course curriculum, like if you can see here, as part of your Kubernetes module is concerned, we'll be discussing about the architecture. Already we talked about the Docker Swarm and Kubernetes differences, right? And you understood the purpose of container orchestration. So now we'll be discussing about the architecture. And as part of the architecture, we need to be clear with the components and the terminologies. And then we'll discuss about the installation of Kubernetes. What are the various methods we can use? And we'll see how to work with your Kubernetes architecture components. We'll see how to work with your pods, deployments, rollback, scaling, services, and all of the stuff. Right. So before we get into this topic, do you guys have any question related to Docker module? Any question? All right. So as we discussed already, Kubernetes is an open source container orchestration tool, right? And it is promptly used to deploy your containerized workload. Okay. Like if you remember in our DevOps introduction module, we were talking about the continuous delivery and continuous deployment. Remember? You guys remember that? What's the difference between continuous delivery and continuous deployment?
In continuous delivery, we require manual approval. In continuous deployment, there is no need of manual approval.
Okay, so in order to achieve continuous deployment, what is the basic requirement there?
In continuous deployment, we are automating the process.
That's what in order to
There
automate
is
the
no
process.
downtime there.
Yeah, there is no downtime. That's fine. But what is the prerequisite? Like if I want to work in continuous deployment process, and if I'm not interested to have any downtime or manual approval, so what is the basic requirement or prerequisite there?
So we need to create a high availability architecture requirement based on that.
Yeah, that is a point we need to do. But to create that architecture, high level availability architecture, what is the requirement like?
We need microservice based applications.
Yes, so that is what the point, right? So using your continuous delivery and deployment, we can able to easily deploy your changes to the target environment, right? But when you talk about the application architecture, if your application architecture is monolith application architecture, we cannot achieve continuous deployment. Only continuous delivery is possible. So if you want to work with your continuous deployment, your primary requirement is the application architecture should be based on microservice-based architecture. So with this, you can able to achieve your continuous deployment. Hope you're clear with it.
Yes.
Question or any doubts on that?
No, sir. It's
Okay. So how we can able to use this microservice-based application architecture and ensure high availability? Because if you can see here in this continuous deployment, I've also added one point. So using continuous deployment, we can able to deploy to production environment without any downtime, right? So you can have thousands of microservices. Each and every microservice can be independently developed, tested, and promoted to the target environment, and also it can be deployed to a production environment without any downtime. So in order to ensure that, we use something called Kubernetes. So Kubernetes is used to achieve your continuous deployment. Okay. Build applications without any downtime. Easy. Am I clear with the point, all of you? So when it comes to your real-time environment, it is completely the responsibility of a developer to create the application source code. And once the code is ready, they'll be pushing the changes into source code repository. And once the source code repository is ready, from there we'll be performing the automated application build using Jenkins. And it creates an artifact. Once the artifact is ready, based upon the artifact, using Docker, we can create an application image. And once the image is ready, will be publishing that image to the container registry. This is what we did. Once the images are available in the container registry, how you can able to deploy it to the target environment. If I have thousands of microservices, you'll be having thousands of images created. Each and every microservice can have its own image. Practically, we cannot pull those images to the target server and deploy it, right? Can you able to do that? Can you use a Docker pull command or run command or Docker compose to do that? No, it's not possible. So we have to create such a huge list of containers, and the Kubernetes is one of the container orchestration tool through which you can able to deploy such a huge list of microservice application architecture without interrupting other deployments or upgrade. Right. So in order to implement this, we have to be very clear about the architecture. That is Kubernetes architecture and its components. So this Kubernetes architecture, right, it is basically referred as the Kubernetes master and Kubernetes worker nodes. Like you can have a number of worker nodes as per your need. It is something as like how you used your Jenkins master and slave node. Here we call it as Kubernetes master and worker nodes. So the collection of worker nodes, we can call it as a Kubernetes cluster. Okay, these are some terminologies you need to understand. So Kubernetes cluster means it is a collection of worker nodes. Right. So here, this cluster has 5 worker nodes. That's what you should understand. Like this, as per your requirement, we can able to have n number of worker nodes. So what these worker nodes are actually, it is nothing but your target servers. Like you can able to consider as a production servers. So in our initial days, we were talking about the various environments. Like we have something called non-prod environment and production environment. And under non-prod environment, we have your dev, QA, UAT. And in production environment, we have some production servers. So more than one servers are available here to ensure high availability, correct? Do you think a production environment has only one production server? No, we'll be having multiple production servers, like replicas of production servers. And each and every server will be having the applications deployed. So Kubernetes worker node means you can consider it's like a server where you actually deploy your services. So in your production environment, if you have 10 production servers means, and if you want to deploy your applications into the production servers, you can consider all those production servers as a Kubernetes worker node. Easy. And like this, you can able to create a number of test environment, build environment, everything is possible there. So this Kubernetes master, it is used to create schedule the pods for deployment. When I say pods, you can consider it as a collection of containers or one container. Okay. And this Kubernetes worker nodes are considered as a target server. Okay. Where the actual deployment happens. That is your application pods or containers. Okay. So we never deploy any application pod in your Kubernetes master node. all your application services, microservices, everything will get deployed in this worker node only. Understood, all of you? At least you're getting some background, right? What is the master node? What is a worker node? What is the purpose of it?
Yes, sir.
So what is a cluster now? Kubernetes cluster. It is nothing but the collection of worker
worker nodes.
nodes. And worker nodes are something where you actually deploy your applications and running it as a pod. And master node is just to schedule your pod for deployment. It just schedules your pods to run in the worker node. You see? Are you clear with this background, like on a high level?
Yeah.
Yes.
So, sir, this Kubernetes master will decide on which target server this service is going to launch.
Yeah.
Or else the pod is going to deploy,
Yes.
right?
Yes. And how it will decide which component is responsible to decide that scheduling. That's what we learn in this architecture.
Load balancing in the sense which server is free now, or which worker node is free now. It will decide and it will deploy a pod.
Yeah, it is having its own scheduler. We'll
Okay.
be using that now. So I'll show you one quick architecture diagram for your reference. Let me pull one architecture diagram for you. 1 minute. Okay, so hope you all can see my screen. Listen, all of you, please pay attention. I need your attention. It will go at least for next 30 to 40 minutes. So please pay attention. So yeah, this is the architecture diagram of your Kubernetes. Okay, and if you can see here, it all starts from the developer. Developer is responsible to create the application source code, perform the application build, create the artifacts, and based upon the artifacts, they can create an application image. The Docker container image using Docker build command, the Docker image will be created by this developer. Once the developer creates that image will be published to the container registry like Docker Hub. Correct? That is what we did. So what are the activities I said here? We have performed all these things with the help of Jenkins. And also we have used Maven to create the artifacts. Once the artifact is ready, using Docker file, they can create the application image, and that image can be pushed into the container registry using Docker CLI command. Are you clear with this process till now?
Yes.
Yes.
So now the image is present in your Docker Hub registry. And I want to bring that image to my production servers, target servers. Directly, if I try to use the Docker pull command or run command in the target server, in real-time environment, I'll be having n number of target servers. And as per the requirement, I can able to add more target servers or reduce the target servers. So practically, we cannot do all these things through our manual approach. We need a automated deployment tool. And if it is for your containerized workload, we need a container orchestration tool called Kubernetes. So as I said, the Kubernetes is based upon the Kubernetes master and worker nodes. Assume that in this architecture, I have one Kubernetes master node and 3 Kubernetes worker nodes. So these 3 Kubernetes worker nodes are called as a collection of worker nodes are called as
Kubernetes cluster.
Kubernetes cluster. So it means in this architecture, this Kubernetes cluster is having 3 worker nodes. Just for an example, I'm saying. And I have one master node. So basically, this master node is something responsible to schedule your pod to deploy it in the corresponding worker node. Correct? This is on a high level. Now, this developer, once they publish the image to the container registry, he will be preparing the application configuration file. This is what we call it as a manifest file. Remember, in a Docker Compose, we have written a manifest file, right? That talks about the property of a container, the services, images, and all. Similarly, here, developers will prepare this manifest file, and it will be in the form of YAML scripting or JSON file format. It can be a YAML file or a JSON file. We'll be preparing this manifest file. I'll show you how to create a manifest file, what are all the entities we have. Everything I'll show you once we start working on it. But as of now, understand, developer will be providing all the detail. Let's say he wants to deploy one pod. What I said about pod? Pod can execute a container, correct? So to create a pod, we have to pass some required parameters, like what is the name of the pod you want to create, within the pod, which container you want to execute, and to execute a container, which image you want to use, what is the name of the image, which version of image you want to use, and whether the container needs any volume or whether it needs any port mapping, right? Any service definitions, right? And whether it needs some any input files. Correct. So like this, all the required parameters will be defined in this manifest file, and it will be saved as a YAML scripting, YAML file based on keys and values. So once the manifest file is ready, we have to submit this manifest file to Kubernetes master. So how we can able to interact with Kubernetes? It means as a developer, how we can able to interact with Kubernetes master means by using a command line utility called kubectl. So kubectl is a command line utility. As like Docker, as like Maven command line utility, we have something called kubectl that is something used to interact with the Kubernetes master node. So developers, once the manifest file is ready, using this kubectl command, they will submit this request for deployment. So this request contains all the required parameters to deploy or define your pod. Once we submit the request through kubectl, in Kubernetes master node, there is a component called API server. The first component you can consider. So this API server acts as an interface between the user request and Kubernetes master. Means whenever you try to interact with Kubernetes, first you are actually interacting with the API server. So what the API server will do means it will receive the incoming request and it will validate the request. Request validation means it starts from the user who submits the request. Let's say as a user, if I submit a request for any deployment, first the API server will verify the user, whether the user is an authorized person or not. Correct? Because as like that, I can't deploy anything in production, right? I should be an authorized person. So this API server, first it will verify the user's authentication and authorization. Once the user is okay or ready with that, once the authorization is successful, then it will verify the manifest file which is prepared by him. It'll check for all the syntax errors, and if there is any configuration mismatch, everything just validate. And if that config file is feasible for deployment, it will update that manifest file or the request details in the etcd. etcd, it's a kind of a database, or it's a kind of a directory that is maintained in your Kubernetes master. So what is the need for this etcd? Means it maintains a complete information about your Kubernetes, like how many worker nodes are there, what is the property of the worker node, and how many pods you deployed, what are the users having access. So this etcd acts as a single point of source of information. Tomorrow, even as a developer or as a user, if you want to quickly check the status of the pods or containers, we are going to actually retrieve data from this etcd. You see? So Kubernetes maintains this etc directory to maintain all the information about your Kubernetes, about the nodes as well as the pods. So once the request is updated in this etcd, let's say, for example, your API server receives the request and it has updated the request in this etcd. Once the request is updated here, your API server will notify the scheduler. Scheduler is the next component. There is a third component which will get into the DCD through API server, and it will try to identify the requirement, and it is responsible to identify the healthy node for deployment. For example, consider I have created my manifest file to deploy a pod. And to deploy a pod, my requirement is I need to deploy it in one server which can able to handle 500 GB of volume. This is my requirement, 500 GB of hard disk, HDD disk. This is a requirement, okay, because my pod or my container needs at least 500 GB to process. So now the scheduler will get the node details, and out of these three nodes, which node is capable or which node is healthy. It will identify the healthy node and assign the node name against the request. So it means completely it's a scheduler's responsibility to identify the healthy node for deployment. Clear? So once it identifies the node, the details of the node will be updated against this request. Now this request is updated with the node details, correct? Once the request is updated with the node details, API server will take the detail and connect to the respective node, worker node. And in any worker node or any Kubernetes node, whether it is a worker node or a master node, we have something called kubelet. It is an agent. Kubelet is an agent that runs in all the nodes. So API server will connect to that node and interact with the agent which is running that node. So the details of the request, the pod details, the container, image details, everything will be shared with the kubelet through API server. Now this kubelet will share the container image, because to deploy my container, I need an image, right? That image is present in my Docker Hub registry. So this kubelet will share the image details, everything to the CRI. CRI means container runtime interface. We can use something called container D as a CRI. So using this CRI, your kubelet can able to connect to this Docker Hub and search for that image. Once the image is present, it will download that image. CRI will download that image to the cluster. Once it is downloaded, kubelet will deploy that image in that cluster or in that node. I repeat, kubelet is an agent that is actually going to deploy a pod in the respective worker node. How it will deploy the pod means the image references whatever collected from API server, it will be shared with the CRI. CRI is a container runtime interface. As like Docker, here we use something called container D. So that container D will connect to the respective Docker Hub registry and search for that image and pull that image into that machine. Like this, all your thousands of microservices images can be pulled using the CRI automatically based upon your request. Once it identifies the image, kubelet will deploy that image in that node. So here the deployment, you can see the circle, what you're seeing here, it is a pod. Got it? The circle, what we're seeing is a pod. And as I said, pod can run a container, right? You can consider the blue box, what you're seeing here, it's a container. So kubelet will deploy the container and run as a pod actually. A pod can have one container or more than one container. So if you can see the difference here, these pods you can consider as a single container pod, but this is multi-container pod. So more than one containers also can be executed within a pod. It is pure depends upon your specification here. Hope you are following.
Yes.
Now, kubelet has deployed the pod into that node. And whenever we deploy any pod, right, each and every pod will be allocated the unique IP address. It is something used to refer the pod or identify the pod. How this IP address will be assigned? Means by using this kubeproxy. So kubeproxy is used to take care of the entire pod networking. It is responsible to allocate the pod IP address based upon some network plugins like Funnel Network plugin or Calico Network plugin and all. I'll show you what it is all about. And it is also responsible to enable the pod networking. Pod networking means, consider I have deployed some number of microservices and it's all running as a pod. I have these four pods responsible to run a service. So once we deploy a pod should communicate with another pod, right? There are some chances, no? Similarly, a container can communicate with another container of that pod. Or if you have a pod with more than one container, within the pod itself, the container can communicate with each other. So how the networking, this is what we call as a pod networking. How the network between the pods are established means by using kubeproxy. So kubeproxy is something responsible to ensure the pod networking. Easy? So the interpod communication or intrapod communication, all these things can be performed with the help of your pod networking. I'll talk about your pod networking separately, but as of now, understand the importance of your kubeproxy. Any question? Now, apart from all these things, we have something called controller manager. So the role of controller manager is to ensure that the pod, whatever we have deployed, it is running as per the desired state. Okay. It is running as per the desired state. I was talking about the self-healing and all, right? It's all taken care by controller manager. For example, consider in this manifest file, developer has requested to have 5 replicas of pods. At any point of time, 5 copies of pod should be up and running to ensure high availability. That is my requirement. Due to some reason, if one pod is down, Kubernetes can automatically spin up a new pod to run it in a desired state. So it is completely responsibility of a controller manager to ensure that the pods are running in its desired state all the time. Correct. Desired state is there, actual state is there. Actual state is the actual running state. Always it should be based upon the requirement here. Easy. So these are all the components of your Kubernetes architecture. So when you talk about the Kubernetes architecture, first you'll be talking on high level as a Kubernetes master and worker nodes. And in any Kubernetes master node will be having the major components like your API server, etcd, controller manager and scheduler. And also will be having something like kubelet, kubeproxy, and containerd as a CRI. Right. Any question on this architecture? Any question on this architecture diagram?
Sai, hello Sai.
Yeah.
So this setup should be, like it should be in like a one Kubernetes master server, or else how it works.
Here in this architecture, I have 4 VMs.
Okay.
Correct? 1 for master and 3 for worker nodes.
Yeah, worker nodes.
Like this, as per your worker node, you will be specifying your VMs actually.
Okay. Okay, got it.
Hope it's clear.
It's clear, sir.
All right. So any other question from anyone? No doubts?
Sai, could you repeat that scheduler task? What is scheduler doing?
Scheduler, right?
Yeah.
Okay, don't worry, I'll talk about it. So if you want, I can give you a quick summary of all these things, all the commands, whatever we have. I mean, what all the components, whatever we have discussed so far. Okay. Just a second. I'll do one thing. I'll just give a summary of all these things so that it'll be easy for you to remember, I guess. Huh? Correct? So what are the components we have in this architecture diagram?
kubectl, API server, control manager, etcd, etcd,
Okay.
scheduler, kube proxy,
Okay.
kube proxy, and CI, right?
CI.
CI, the Docker, the third block, which will collect the image from registry. Which will pull the image from registry.
Okay. No problem. So let me put it in this way. So I'll update all the contents here first. Where's the notes? There you go. There's the notes, right? Okay. So on a high level, at least you understood what it is all about. Now I'll just talk about all these components of Kubernetes architecture. I'll just give you the description for all these things, okay, or a summary of it. So first, we have Kubernetes master node and worker nodes. So in any Kubernetes architecture, we'll be having a component called API server. And we have something called etcd. And we have something called scheduler. And then controller manager. And on the other hand, we have something called kubelet, your kube proxy, and CRI, that is container runtime interface. Okay, container runtime interface. That means your for this case, we'll be using our containerd. Containerd is one of the CRI recommended by Kubernetes, right? So you'll be having a Kubernetes master node, right? So in master node, you'll be having API server, etcd, scheduler, controller manager, and kubelet, kube proxy. It will be there. And what is the purpose of API server? It is used to interact, or I can say like receive the request and validate, and it acts as an interface. It acts as an interface between the user and Kubernetes master. Correct. So any request you want to process, it will be received by API server first. It will do all sort of validation. Once the request is valid, it will update details in etcd. Similarly, if etcd wants to interact with, or if any other service wants to interact with any other service, right? So this API server acts as an intermediate component, acts as an interface. And this etcd is a kind of a data store. Okay, it is a data source. maintains the information of Kubernetes. So it acts as a single point of source. So any information you want to read, or let's say I want to check how many worker nodes are there in my cluster, or I want to check how many pods are up and running, or I want to check how many pods are not, how many nodes are not reachable. All this information can be fetched from this etcd. And the next thing is about scheduler. This is used to, based on the request, it will identify the healthy worker node for deployment of pods. Understood? So scheduler is a component representing Kubernetes master node, which is promptly used to identify the healthy worker node for deployment. Is that clear now? Or any question?
Yeah, got it. So on which worker node this pod has to be deployed, it is taken care scheduler, right?
Yes. And next thing is about the controller manager. This is something used to execute or to maintain the desired state of the pods, or I can say like to run pods in its desired state all the time. So it means, consider I have mentioned a replica as 3. To deploy a pod, to deploy my application, I need 3 replicas of pods. That is my primary requirement. So when I say replicas as 3, it means at any point of time, Kubernetes should maintain 3 copies of pods. As like containers, pods also, it is not a permanent entity. At any point of time, pod might get into exit state. Correct, but as per my requirement, it should be up and running. Even if one pod is down, your controller manager will automatically create a new pod and maintain the desired state. That's what is self-healing actually, right? That will be taken care by this. And another thing is your kubelet. It is a Kubernetes agent responsible to deploy the pods. So this kubelet agent is something responsible to do the actual pod deployment, not any other component. All of the components just to support, but kubelet is something responsible to deploy it. And kube proxy is something used to set up the pod networking or communication. So we have a lot of Kubernetes services like node port service or cluster IP service or load balancer service. And in order to enable all the services, we'll be using some identity, the pod IP address, right? So all these things, the pod IP address and the process communication can be done with the help of your kube proxy. And another thing is about the CRI. This is something used to identify with container registry and identify the images, or I can say like contain images for deployment. The amount of pods we can say. Okay. right? Any question? So these are the components we have seen in our Kubernetes architecture. Any question on this? Please let me know. You all able to understand, right, the purpose of it?
Yes, sir.
All right. So in addition to these components, we are also seeing some of the terminologies or the concepts here. So we have seen something related to your so let's say for an example, we use one term called kubectl. We use a term called pods. All right, can select pod for now. And also we use a term like, what is it, container, right? We use a term called images. And we talked about the container registry. Okay. Right. And also we talked about the Kubernetes cluster. Remember? What else? Right. So these are all some terminologies or concepts we have here. And what is kubelet basically? Or kubectl is a command line utility to interact with Kubernetes master node. If you want to interact with your Docker engine, what you used? To interact with Docker engine, what we used? We use Docker CLI, correct?
So,
We have used Docker CLI to interact with the Docker engine. Similarly, here to interact with your Kubernetes engine or Kubernetes master, we use kubectl. It is also a CLI commands. That's why it is called as a command line utility. So through this command line utility, we can able to submit the request. We can submit our manifest file for deployment. If you want to scale up or scale down. So all sort of interactions can be performed with the help of this kubectl. I'll show you how to use kubectl and all one by one and what are the commands we have there. Correct. And the next important thing is the pod. So as of now, you just consider pod as pod is basically called as a smallest or atomic unit of task. It is the smallest or atomic unit of task schedule to run in Kubernetes. So in Kubernetes, any smallest task or atomic task, atomic smallest, right, minute, that you execute, it is executed as a pod. And already you know what is a container and all, right? In our Docker models, we talked about, remember, what is a container? Guys, hope you all remember these terms. The container, images, container registry, repositories, right? So all these terminologies are actually being used in our Kubernetes as well. With respect to the containers. Easy. Any question on this? And what is the next one? The Kubernetes cluster. So what is it about Kubernetes cluster? It is a collection of worker nodes. It is actually a collection of worker nodes. It is just a logical grouping of your worker nodes, you can say. Understood? Any question here? So these are all the terminologies you need to be very clear. Any questions, guys? Try to understand the terminologies alone. Okay, don't worry about how to work on it or how to create all those things. That is what we're going to do for next two or 3 days. But as of now, if you can understand the purpose of this, that's more than sufficient. Why no response? Am I audible?
Yes, clear.
Okay. All right then. So I'll be giving you some of the concepts which you're going to cover here, like as part of this module. So you need to be very clear about the kubectl commands. What are all the commands we are going to use? You have to be very clear. And then you need to be very clear about the pods. What is a pod? How to deploy a pod? What is pod networking? Okay, what are types of pod networking? And we'll be discussing about the controller objects. Like here we'll be using one control object called deployment control object. Okay, and then we'll be discussing about the Kubernetes volumes. It means we'll be talking about the host path volume. Host path volume is one of the volumes in Kubernetes. We'll be discussing about that. And what else? We'll be talking about the namespaces. And we'll be discussing about the services. Okay, actually, while working on this pod networking, other stuff itself, we'll be discussing about the services. From there, we'll be learning about the Kubernetes controller object next. Easy. So these are all the topics we are going to cover as part of this module with a demo. Okay, but before you actually work on this demo and all, we'll be focusing on the installation and configuration of Kubernetes master and worker nodes. This is very important task to be completed before we do that. So any question on these things? If you want, just take another 2 minutes to understand whatever we discussed, recollect the points, and let me know if you have any question, please. If you're clear with the architecture, then only you can able to work on Kubernetes. Any question? I can keep the slide here itself, page. Just read it one by one and let me know if you have any question. For some of you, weekend already started, huh?
We can have more than one worker nodes and connect it to a master.
It is recommended to have at least 3 worker nodes.
Okay.
We can have more than that as per the infrastructure.
So all the worker nodes will consist of the architecture you have explained just now. Same thing, 1, 2, and 3, and they will be connected. And the same process will happen with that scheduler will work like we connect with the three worker nodes and select the that pod timing and all.
Yes, yes, it's common.
Okay.
right? So are you clear with what is Kubernetes? During interview, it will be a very first and important question. So you have to be very clear about it.
So Docker will be used for image uploading and downloading, and the containerization concept is already implemented in Kubernetes.
Again,
No, I'm asking.
what's the question?
I'm asking Docker, we will use Docker here for image purpose.
Docker, it is used to create your container engine. Sorry, create your container images,
Yeah,
right?
yes,
And once the image is ready, using the Docker, you'll be publishing it into the container registry. Correct?
yes.
Once that is completed, then your kubectl will take the response. Through kubectl, you'll be submitting a request. And as per your manifest file, the request, your deployment of your pods will happen in the cluster. So in Kubernetes cluster or in Masternode or Worknode, we never use any Docker commands. You're getting?
Yes.
Sai, is Kubernetes a tool or a service?
It is a container orchestration tool.
Tool, right?
Yeah. Let's scroll down. Yeah. Go through this architecture components.
Looks like, can you tell me what does a control manager really do? I can't able to recollect actually.
I said controller manager. It is used to run the pod in its own desired state. It means if I say pod should have 3 replicas, means at any point of time, 3 replicas of pod should be up and running. Right? That is my desired state. Correct?
So it is a standard thing, or of any time the 3 pods has to be running.
I'm just giving an example. It can be 3 or 10 or 100. It depends
Okay,
upon the
okay,
requirement. So the
okay,
desired state, whatever your desired state of your pod, right? Whatever
okay,
your replica count, your controller manager will ensure that the pod is running in its own desired state as per your requirement.
okay, okay, yeah.
So if a pod is going to die, the controller manager is going to recognize, oh, this pod is going to die. So I should create a replica.
Yes.
And it
So
will
yes. So let's say I have deployed my pod, and as per my requirement, I just deployed 5 copies of pod. 5 is my replica count. At any point of time, 5 copies should be up and running. Okay, that is a desired state. So during the process of execution, due to some reason, if any one pod is not responding, or if it is in hung state, if it's not giving any response to the application, means your controller manager is continuously monitoring the pod and its state. Correct. So if any pod is not running as per the desired state, the controller manager will immediately respond and create a new copy of the pod and keep it in its own desired state. Correct? That is what we call as self-healing here. Are you getting a point? So if
So,
it
sir,
is getting into the drain state, if a pod is getting into drain state, or if it is unable to respond, if you're not able to get any response, it creates a new pod and deletes this pod which is unhealthy.
okay, it is, yeah, that is what I was about to ask. So it is going to kill the previous pod, which is like unhealthy.
Yeah, which is unhealthy, it will get deleted. I'll show you with a demo, okay, how it works, everything.
Does it work for load balancing also?
We
Control?
have a separate service for that. We have a load balancer service. Through that load balancer service, we can able to ensure load balancing.
And auto scaling also.
Yes, auto scaling can be done through Kubernetes. We have a controller object, right? So the controller object can able to perform the, controller manager. Here we're going to talk about the controller object called the deployment controller object. So this deployment controller object can able to perform the auto scaling.
Okay.
So, sir, in a way, scheduler is doing that load balancing only, right? So it is saying which is healthy to be deployed, which worker node is healthy to be deployed. It is
Scheduler, it is just going to identify the healthy node.
healthy
It is
node.
not going to load balance it, right? Load balancing what? It just distribute the workload, correct?
Yeah.
And also identify the services when you try to invoke it. But scheduler is not like that. Scheduler is just to identify healthy node, that's all. Even it is not going to do any deployment.
Deployment. When it comes to deployment like auto scaling, so
It will be taken care by the controller manager and kubelet agent.
okay.
See? You guys able to follow these things? Easy, right? Okay, so if you're clear with this, then we'll talk about these terms one by one. Because all these things are something associated to your architecture, right? I talked about kubectl there. We talked about the pods, and a pod can be deployed and it will be having the IP addresses, right? So it's all associated to your cluster. So when it comes to cluster, you need to be clear. Architecture, you need to be very clear about the architecture components and then the terms, what are we going to use here. So please go through these things and let me know if you have any question. Terminologies like kubectl, pod, images, containers, container registry, and all already you are familiar with. Correct? All good?
Yes, then.
Okay. So now we'll see about your kubectl pods, all the things one by one. Let's understand this. And the actual demo I can provide you once we do this installation. And this installation itself, it has a lot of process. Okay, it's one of the critical when you say. It is not like how we installed our Jenkins or Git or Docker just with one line command. It has a lot of steps to be performed. Okay, so I'll share the details as well. But before that, I want you people to be clear with these terms, like what is kubectl commands, pods, and everything. So let me pull those details for you. Fine. So when I say kubectl, kubectl is actually a command line utility through which you can able to interact with your Kubernetes master node. And these are the commands we can say. This is a syntax really. kubectl command followed by the type of Kubernetes object which you're going to work, and what is the name of that object. And then if the object is having any additional parameters, you can able to pass it as a argument, the flags. So any kubectl command will be having the Kubernetes object type and the name. So out of this, your command list can be anything. Like, let's say I want to create a pod, means I can say kubectl create as a command, and what I'm going to create. I'm going to create a pod, and what is the name of the pod I want to create. So the command will be kubectl create pod followed by the name of the pod. Similarly, once the pod is created, if I want to get the list or details or status of the pod, I can use kubectl get command. Kubectl get pod followed by the name of the pod. So pod is a type of object and get is a command, and nginx-pod is the name of that pod actually. You see, like this, if you want to interact with Kubernetes to work on any Kubernetes object, like deployment, replica set, we'll be using this kubectl command. This is one thing. I'll show you. We have a lot of scenarios. I'll show you all those things one by one, but promptly we'll be working on your pods actually. So ultimately, what does a pod means? Pod is just a smallest unit or atomic scheduling, whatever we're going to do in your Kubernetes. Any smallest task you execute in Kubernetes is called as a pod. It is just a terminology, okay? Like, don't think it's something different things and all. Like, for example, in your virtualization, we use virtual machines. In Docker, we deploy it through your containers. It means how your applications are deployed. If it is a simple monolith application, if it is not a containerized application, we can directly deploy in your VM. If it is Docker, if you're using Docker, means you'll be running your application in the container. Similarly, if it is in Kubernetes, the same application can be executed in the form of pods. Got it? So now, what is this pod is all about, and how we are going to deploy it? Listen carefully. So let's say, for an example, I have a manifest file created by the developer. This manifest file gives a complete picture about the pod which you want to deploy. What is the name of the pod? What are the objects you're going to have? Everything. Correct. And once the manifest file is ready, using kubectl, we can submit this, and your API server will take care of all the validation. And once the node is identified, the API server will interact with the node. Consider this is my cluster. What I said about cluster? Cluster is a collection of worker nodes. So this is node 1 and this is node 2. So it means in this cluster, we assume that we have two nodes, node 1 and node 2. So when you deploy your pod, the pod can be deployed in any available node based on the status, health status of the node. So a pod can be deployed with one container. The circle, what you're seeing, right, it is a pod, and within the circle, the blue box, what you're seeing here, it can be considered as a container. So pod is actually used to run a container here. Right, it is used to run a container, and you can able deploy a pod with one container or multiple container. It's possible. So if you can see this example, we have deployed a pod with one container, and this pod is running with two containers. So pod is capable to run multiple containers. Technically, it is possible, but as per the best practice, we never recommend that. It is always recommended to deploy a pod with one container, so that it will be easy for anyone to manage. Got it? It is always easy to manage your pods if it is having only one container. Clear? And the worst case scenario, if you need more than one container, means in that case, a pod will be having one main container, and this can be considered supportive container. This is the main container. So what is the need for this main container? Means this main container is what going to have my actual application image. This supportive container, it is just going to support this main container with some data. Let's say this main container needs some inputs. That input can be processed by this supportive container shared with the main container. We call it as a sidecar container for supporting your main containers. Understood? So as per the process, it is always recommended to deploy a pod with one container. And once a pod is deployed, how we are going to establish the communication with the pods? That's what we call it as a pod networking. So when I say pod networking, it is just to enable the communication with the pods. So how it is possible means, as I told you already, there is a component called kubeproxy, remember, in your architecture. So in your Kubernetes architecture, there is a component called kubeproxy that is responsible to assign the unique IP address to a pod and also enables the pod networking. So by default, there are two types of networking. One we call it as interpod networking or interpod communication, and another thing is intrapod communication. Interpod and intrapod. Interpod means communication between the pods. Let's say I have deployed two pods. Okay, we have deployed two pods here, and my requirement is I want to communicate between these two pods. So as I said already, any pod we deploy, the pod will be allocated with a unique IP address. Let's say this is the IP address of pod 1 and this is IP address of pod 2. And within the pod, we can have more than one container or just one container. There should be one main container and a supportive container, you can say. And any container you deploy, right, it will be having its own port number. Let's say if you're running a Tomcat image in this container, the container port will be 8080. If you're running Nginx container means it will be having port 80. Correct. So like this, any container you execute, it will be having its own port number. So what does the purpose of this port number means? Tomorrow, if you want to communicate between the ports, in that case, these port numbers will be used to uniquely identify the container. Say for an example, if you look into the scenario here, this pod 1 is assigned with this IP address. Similarly, pod 2 is assigned with this IP address. And in pod 1, we have two containers. Container 1 is assigned with port 8080 and container 2 is assigned with port 3000. So how these containers are referred means with the help of your pod IP address. So this is the identity of the container. Using the IP address of a pod followed by the port number. Similarly, this container is identified with the help of the pod IP address and the port number. Like this main container will be referred by this. So tomorrow, if you want to transfer the data from the main container of pod 1 into the main container of pod 2, we'll be using this IP address and the port number for reference. Easy. So this is what we call as interpod communication. Between the pods, how the communication happens. This is one scenario. So in order to perform interpod communication, what we need? We'll be using the pod networking, that is pod IP address and the respective container port numbers. And apart from that, there'll be some scenario where we need to interact between the containers within a pod. Like in pod 1, we have two containers, main container and supportive container. If you want to communicate between these two containers within a pod, we call it as an intrapod communication. Hope I'm clear with this terms. Now, in order to establish this interpod communication, either you can use the IP address of a pod followed by the port number, or within the pod, you can able to use localhost. The term localhost can be used for the purpose. Easy. Localhost followed by the port number. Am I clear? So I'll show you, okay, all these things I'll show you. Once we start with the implementation, I'll show you how we can able to access all these things one by one. Easy. So that's it about your pod communication. And another interesting thing here is, listen carefully, there is something called pod life cycle. Pod life cycle. This is also another essential thing. For example, consider I have prepared a manifest file, and once the manifest file is ready, I'll be submitting the manifest file, right? As soon as I submit the manifest, what happens actually?
The API server, it is gonna read the request.
Yes. So your API server will validate your incoming request. It will verify the user access, everything. And once it is valid, then only it will deploy or schedule for deployment, right? So till the time the status of the pod will be in pending state. As soon as you submit, immediately it won't go into running state. It will be in pending state. It means your API server is performing all sort of validation and the scheduler is identifying the node and it is getting deployed. Once it is deployed successfully, the status of the pod will become a running state if it is successful. Due to some reason, consider the user authentication or the manifest file definition, it is not as per the requirement. If there is any issue, by the time it will go to fail state. All right, it will go to fail state there. Now, from this running state, let's say my pod is up and running, it is successfully deployed. Due to some reason, it might go to fail state. There might be some resource unavailability, or there might be some system issues. Whatever the reason it is, from running state also the pod can go to fail state. Or if everything is working as expected, it will go to succeeded state. So when you deploy a pod, how to get the status of a pod means we use a kubectl get command. Kubectl get pods. This command will quickly give you the name of the pod along with the status of execution. Easy? All good?
Yes.
Fine. So that's it about your pod and kubectl. Okay. So instead of going through all the things, let's talk about the installation and we'll see all the things with the demo. That will be more relevant. You want to have a quick break or shall I proceed?
We will have.
Sure, sir.
Okay, then go ahead. Yeah, just have a quick break and come back. We'll continue with the installation process. And then once the installation is complete, I'll show you how to create a pod, deploy the pods, how to verify the access, everything. Sorry.
Sai, while uploading the notes, you are going to upload those presentations also, right?
I'll be sharing the resources of that from where I took it,
Oh,
right? I'll be sharing that.
oh,
It is just a simple slide, okay? Don't follow any static document like that. I'll be sharing the source of the document, don't worry.
oh.
So shall we?
Yes.
All right. So throughout the process, okay, throughout your DevOps process, we are at the final, just the final stage of your DevOps. That is your CI/CD. Already we talked about continuous development, continuous integration, and now we are in the process of continuous delivery deployment using Kubernetes, right? So throughout the process, we have installed various tools, but this is something very crucial. And in order to work on this Kubernetes installation, it's open source Kubernetes, I told you. Apart from open source Kubernetes, we have something from your service providers. So we are not going to discuss all those things now. Let's focus on the open source Kubernetes master node and worker nodes. So I'll share one official documentation for this. Listen, please. Hmm. So this is the official page from where you can able to download and install Kubernetes. So as part of Kubernetes installation, right? Listen carefully. The Kubernetes can be installed in many methods. Okay, so if your intention is just to learn about Kubernetes, if you just want to learn about Kubernetes and its concepts, you can use a method called Minikube. So Minikube is a very primary way to install and set up a Kubernetes cluster. But in a single node itself, you can able to configure it. It's very easy. You just need only one node to set up a cluster. And once it is done, you can able to practice all these pods, everything. So it is just for learning purpose. But if your intention is to implement in the production level, right, you cannot rely on this process. In production environment, we never use such things. We use kubeadm. So using kubeadm, we can able to bootstrap the Kubernetes cluster and manage it. So this is something recommended to implement the production level. Correct. So whether you just want to learn about the concepts or you want to learn about the production level implementation. Hmm? What happened? What happened? Why no response? Guys, I'm audible. What happened? Why no response?
Yeah.
Yeah, you're audible.
I'm audible. You should respond, right? Okay. As a matter of interest, I'll show you how to work with your kubeadm, which will be very much helpful for you to, add value to your profile. Minikube, it's not that required. It is just for learning purpose. If your intention is just for learning, you can use it. Otherwise, I strongly recommend to use kubeadm utility to implement your Kubernetes components. So how to set up this Kubernetes cluster using kubeadm? That is what this document is going to talk about. Okay. So if you look into this documentation here, installing kubeadm, and using this kubeadm, we can able to install and configure the cluster. So today I'll be showing you what are all the methods or what are steps to be followed to install Kubernetes. And in the next session, I will show you the actual installation process. I'll give a demo on the next session. So we have various versions of Kubernetes. The latest version of Kubernetes is version 1.32. And if you want to understand the properties of each and every version, just click on that version number and go to that new tab and understand it. Got it? The documentation, whatever you have, it's all based upon the versions. So in order to work with Kubernetes, install Kubernetes itself, there are some prerequisites you need to take care. So it is compatible to your Linux machine. First of all, it can be Ubuntu machine or RHEL or CentOS, it depends. And whether it is a worker node or master node, you have to use at least 2 GB of RAM and at least you should have 2 CPUs. If you're using T2 micro instance, what will happen? It just comes with only 1 GB RAM and 1 CPU, right?
Yes.
Yes.
Your 1 T2 micro instance will come with 1 GB RAM and 1 CPU, which is not sufficient to enable your production level workload. Maybe for this demo purpose, you can use T2 micro and you can able to create some pods. But if you want to execute all the pods in parallel, it is not possible. I'll show you how to do that also. But as per the recommendation for production level implementation, at least you need 2 CPUs or more, and at least we'll be having 4 GB RAM. So you'll be using around T2 medium instance type. Instead of T2 micro, if you use T2 medium, it will be easy for you to work in Kubernetes. And another prerequisite here is full network connectivity between all the machines in the cluster. That means what are all the nodes you have, whether it is your master node or your worker node. And if you have 100 worker nodes, all the nodes should be enabled with proper network connectivity. There should not be any firewall restrictions. There should not be any port restrictions and all. The full network connectivity should be enabled between all the nodes. All right. And another important thing is every node should be assigned with a unique name. That is also very much important. By default, it will be identified with the help of your private IP address. But on top of it, it is recommended to have some unique host name that is required. And then as per the requirement, we need to open certain number of ports in all the machines, like how you can communicate between your master node and worker node, how your master node, worker node can communicate with master node. Like this, communications can be enabled with a certain number of ports. So all the required ports has to be enabled. And there is something called swap configuration. So in order to make your kubelet to work properly, you have to disable swap. That is mandatory. Correct. Swap should be off. It is one of the configuration parameter that should be disabled in order to make your kubelet to deploy your pods properly. And another thing is we have to install the CRI, container runtime interface. And for this demo, we'll be using containerd as a container runtime interface. We have CRIO Docker engine using CRI Docker D can be used as a container engine. But apart from that, we can use containerd as well. Correct. And once this containerd is installed and up and running, then only you can able to go and install your kube ADM, kubelet, and kubectl. And for the installation of all these things also, we have a lot of steps involved. We follow this document. Correct. It's a huge document. And one more interesting thing here is you cannot directly refer this document to install anything, because if you want to install any product, they'll be giving you some reference link actually. For more information, you need to select this particular link and understand it properly. Got it. Like this, there are some hyperlinks enabled in this page. So you have to navigate to a lot of pages to understand the process in detail. That is what we usually do in real time. It's a lengthy process. If you are using your open source Kubernetes, the installation is one of the toughest tasks. But once it is installed, right, then you can simply forget about it. Kubernetes, it will take care of the deployments without any much manual intervention. Are you getting my point?
Yes.
So the point here is you have to understand the fundamentals of Linux, how to manage the packages, correct? The package management, how to install a package, how to install the package using package manager or through any other, extracted files. Everything you need to be very clear. All right. So shall we talk about it now? So it's not that easy. Okay, I'll share the link if you want to just have this link and bookmark this page. Okay, you can bookmark it. So to simplify this process, I have prepared the detailed installation guide for you people, as like how I shared something for Jenkins. Remember this document which we use for Jenkins installation configuration, right? Slave node configuration, your Tomcat server configuration. Remember? Hope you are using this, no? Similarly, have a detailed steps for your Kubernetes. So today I'll just explain you the steps. What are all the steps you're going to perform? I'll just explain you the steps, and from next session we'll be using these things. So as per the requirement, we need to create some virtual machines. Like here for this demo, I'm going to create 3 VMs. VM1 is considered as a master node, and remaining 2 VMs I can consider as a worker nodes. And as per the prerequisite, you have noticed you have to enable all the port numbers. There are some list of port numbers as per the official documentation. Like in master node, you have to enable all these ports. In worker node also, you need to enable these many ports. So instead of that, for the sake of demo, you can allow all traffic in all the nodes. Right. Once this is done, if you can see the official page, they were expecting you to set up some unique host name. Right. So to set up the unique host name, this is a command. So in all the nodes, in master and worker nodes, you have to change the name of that machine because by default it will be referred by its private IP address. We cannot easily remove the private IP address to identify the node during deployment. So you can assign some name for that. So this host name CTL is a command, Linux command, through which you can set the host name. Like this, you can able to set it for your master node, worker node 1 and worker node 2. And once this is done, you can see the prerequisite here is to disable the swap, and there's a command to disable it. Once the swap is disabled, if you want, you can able to install Docker on this nodes, in all the nodes I'm saying. So there are some number of commands or tools should be installed on master and worker nodes. That's what you're learning now. Similarly, there are certain number of commands should be installed only on the master node and something only on the worker node. Correct. So it's a lengthy process and you need a lot of patience and understanding about the process before you actually start implementing it. So today it is just a high level information I'm going to provide, but once we start with this process tomorrow, you can able to see the live demo on all these things. Right. So what are things I was explaining in that prerequisite documentation? It's all available for your reference now. Listen, please. I just summarized with few points. Listen, please. So these are steps. Now to install a Kubernetes using kubeadm, first we are going to launch 3 nodes on AWS Cloud Platform, and all these nodes will be of type Ubuntu 22.04 version. And once the node is ready, in all the nodes, that is your master worker node, you should allow all traffic. For the sake of demo, I'm going to allow all traffic, but in real-time environment, you have to enable only the required number of ports as per the official document. And then we have to change the host name in all the nodes and disable the swap configuration in all the nodes, install Docker in all the nodes, and install container runtime interface in all the nodes. And also we're going to install kubeadm, kubectl, kubelet, and enable the kubelet service because it's an agent. Easy. Any question? Guys?
Yeah, easy. Yeah.
So these commands are applicable to all the nodes, all three nodes. And once this is done, once the kubelet and CRI is up and running all the nodes, only on master node, it means out of three nodes, which node you want to consider the master, on that node you should run kubeadm init command. So this kubeadm init command will initialize that node as a master node. Once it is initialized, you have to enable user access to the Kubernetes and then install some network plugins for kubeproxy. All these things I have given in the documentation separately. Okay, like if you see this document, it's all based upon the commands I've given you. I'll be showing you, I'll be executing all these things command on next session. Tomorrow we'll see how to execute all these things. Okay, but today it's just a summary of what you're going to do. And next thing is, once your master node is initialized, you are going to attach your worker nodes with the master node, right? For that we use kubeadm join command. It's a simple command. And how the master node and worker nodes are attached or authenticated means by using the token based authentication. So this token will be automatically generated during the initialization process. So only this join command will be running in your worker node upon initialization. Any question? Guys?
No.
All right. So I'll be sharing this document also with you people, but this installation guide, whatever we are going to install, I'll be giving you only on the next session once we install it. Once the demo is over, then I'll share this document so that it'll be easy for you to understand it. But for today's session, I'll share these details. And before you join tomorrow's session, tomorrow before you join the class, please go through these steps. Understand at least what are things you're going to do on high level, so that while I'm running the commands, you should not get any surprises. Possible?
Yes.
Tomorrow means next working day. Today it's Friday. Yeah, okay. All right, then we have 2 days time, right? Okay, then it's okay. That's what. It's good that I'll be sharing this so that you can recollect something on before you join Monday session. Just have a glance and come back. All right. So from Monday onwards, it'll be like a complete demo or practical oriented session. There won't be any theoretical part from Monday on Kubernetes. Monday, as soon as we log in, I'll directly show you how to install Kubernetes cluster along with your master nodes, and then we'll deploy some pods, we'll deploy some services, we'll deploy some controller objects, create replicas. All those things we'll see in next session. Any question now? Any question? Guys? If you guys have any question, please let me know. What happened?
No, question, but it is a lot to take in.
Yeah, that's why. Even that's the reason I don't want to install it today, okay? Because already you have to complete your Docker module, right? So you can take next 3 days of time to complete all those things. Complete all your Docker related concepts till your publish. At least you should be able to publish image to container registry. Complete all those things and then go through the Kubernetes architecture, the overview, comparison between Kubernetes and slave. I mean, what do you call it? Docker Swarm. Understand things properly, then we can follow with the installation procedure. Clear? So if you have any question, please utilize this time now. Guys, if you have any question, please let me know. What happened? No questions. Wow. You people are super smart here. Really nice. Hope you don't have any issues in asking questions, right? Or you feel like any hesitation in asking questions. Or any issues in responding. Yeah, I'm available for your questions. If you have anything, please let me know. It's like a doubt clarification or anything you can consider. Utilize these times. Okay, you won't get such times, right? So almost we are at the end of this training. Once we're done with the Kubernetes, just 4 more modules for your open source DevOps services. No, it is not like that actually. Here, the nodes are the actual computing environment required to deploy a pod. You cannot run it in your container. Correct?
Yeah.
So if you want to deploy a pod, it can be deployed on your worker node, that too only through Kubernetes. Correct?
Yes, sir, I got that.
So, sir, you have explained saying in real-time scenario, we will be using one container inside the pod. So, in that case, what is the advantage of using a pod over container?
It is a Kubernetes way of deployment. Okay, Kubernetes will never consider pod. I mean,
Pod.
consider container.
Okay.
In Kubernetes, if you want to deploy any image, application image, it will be wrapped up and exist as a pod. You can consider pod is a group of your container images that you are executing.
Okay.
Correct? It is just a kind of a terminal you can consider. Okay, so the container, whatever you want to execute in Kubernetes, you are just wrapping up and executing as a pod. That's it. right?
I got it.
All right, so I just enable the poll. People who are available, if you possible, you can share your response there. I can see most of the people started to leave without any notification. It's okay. All right, guys, if you don't have any question, you also can leave. I don't want to waste your time. Go ahead, please. At least before you join next session, go through all these concepts and be prepared with the terminologies. I want everyone to be clear with the terminologies actually, starting from your API server, MS, your etcd, and pods, kubelet, kubectl, kubeadm. So because we are going to actually install your kubeadm, kubelet, and kubectl.
Please update the notes and Git.
So all good. All right, guys. Thank you. Thanks for your time. If you have anything, let me know. Otherwise, yeah. Yeah, for scripting language, you can able to refer any online resource. Okay, we have a lot of things for scripting language. I'll share those details. Okay, maybe um, like say if you want to learn about Groovy scripting or YAML scripting, just browse through that. We have a lot of documents available, online references. So once I start creating the pod, right, I'll be giving those references one by one.
Okay, sure. Thank you.
First, let's talk about the installation, and during the pod creation, only we need that manifest file. I'll show you that.
Fine, sir.
Yeah. Yeah, waiting for responses. All good? No, this command is not required. It's a command which we use, right? It's fine.